Quantum computing might seem like something straight out of a sci-fi flick, but it's totally real and getting more practical by the day. Microsoft's new Majorana one chip is a big step towards creating these super powerful machines. Unlike the computers we use now, which follow a set path to crunch numbers, quantum computers operate on a whole different level, thanks to the principles of quantum physics. In this video, we'll dive into what the Majorana one chip is all about, how it functions, and why it's such a game changer for the future of computing. To start with, I'll explain the fundamentals of quantum computing. Actually, quantum computing is a whole new way of computing, using tiny particles smaller than atoms to process information. Think of a classical computer as a single worker checking items one by one, while a quantum computer is like a team of workers who can check many items at the same time because they work together in a highly coordinated way. We all know that the normal computers use bits, which can only be in one of two states, 0 or 1. Think of them like a light switch, either off, 0, or on, 1. Their operations are sequential, where tasks are handled one after the other. Meanwhile, quantum computers use qubits, almost like multitasking workers who can be in multiple states at once. A qubit can be off, 0, or on, 1, or it can be both at the same time. This is called superposition. Further, qubits can become entangled, meaning even if they are far apart, change in one can affect another. This teamwork-like behavior allows quantum computers to work on many calculations, all at once, solving problems that would take classical computers much longer. Essentially, quantum computing has huge potential, but requires careful management to maintain its accuracy and stability. Microsoft Majorana one chip is a new computer processor that could become the cornerstone of future quantum computers. Unlike the chips in today's computers that work with simple on-off bits, Majorana one uses the rules of quantum physics to process information in a completely different way. Named after Ettore Majorana, an Italian physicist known for his mysterious theories and disappearance, the chip reflects groundbreaking ideas in quantum physics. So, how does Majorana one work? Majorana one utilizes topological qubits for calculations, offering enhanced stability compared to conventional qubits. Imagine two paper airplanes, a regular one that struggles in the wind and a reinforced one that stays steady. To create these qubits, Microsoft developed topoconductors, a type of material which can observe and control Majorana particles to produce more reliable and scalable qubits. Topological qubits draw on topology principles to resist environmental disturbances like vibrations and temperature shifts, reducing errors known as decoherence. This is like balancing on a wobbly board in the breeze. To function correctly, Majorana one operates at extremely low temperatures, akin to lab freezers used for sensitive experiments, ensuring more reliable quantum computations. If we talk about the potential applications and implications of this technology, today's quantum chips, including Majorana one, are still in the testing phase but have huge potential. They could create nearly unbreakable encryption for secure data, simulate complex molecules to speed up drug discovery, and even design new materials with specific properties, tasks that our current computers struggle with. Imagine trying to build a puzzle with millions of pieces using just one hand. That's what classical computers are like when tackling these complex problems. Quantum chips promise a more powerful, efficient way to solve challenges that could transform fields from cybersecurity to medicine.